Hi everyone, yes, another Liquid AIO coming from Montech, which is known as the LightFlow ARGB 360. And let's see how light this Liquid AIO is. I'd like to thank Montech to have provided this unit for me to share with everyone. This Liquid AIO does come in two different colors, which is in black or in white. The one I'm having is a 360 black. And regarding about the sizes, it comes in two different sizes, be it the black or the white. It comes in 240 or 360. And surprisingly, the MSRP for 240, be it black or white, is at $63.90, considered as 64 USD. And as for the MSRP on the 360, as again, be it the black or the white, is at $69.90, consider is at 70 USD. These are all the accessories which is packed in the Ziploc bag, and some of this component which is packed in packages like this, they are labeled nicely. Now something to take note, for this Liquid AIO, it's only cater for Intel 1700 socket and the 1851 socket. If you guys are using the 115X or the 1200, this Liquid AIO will not work. And as for AMD, it supports AM4 and AM5. Now you'll be provided with a instruction manual, nicely written. Starting off with the left, you will have the standoff for your Intel, the bracket for you to mount to the pump, and the back plate. As for AMD, it's pretty straightforward. You have the AM4, AM5 standoffs and the mounting bracket again for the AIO, a tube of thermal paste. There's no spatula, there is no template as you see the rest of the Hyperflow series, but anyway, this is LightFlow. 4 retention mounting board for you to cram your block to your processor. 12 short screws. These are meant for you to mount the radiator to the case. And this, I believe, is the extension cable or necessary extension cable for your radiator fans. This is the main unit. I'll start off with the radiator. Kindly note that these 320mm radiator fans are pre-installed. Just happened that I want to show you the radiator. I will talk about these fans in a short while. Now starting off with the measurements, from here to here is 397mm by 120mm. And as for the thickness, this is at 27mm. If you add together with the radiator fans, by the way, this is 25mm, together you will get a 52mm. For the fin stack over on the radiator, measuring at 1 inch, this is 20 fins per inch. The whole build of the radiator is made of aluminium. It's very sturdy. Now this time round, it does not have any logo at the side of the radiator, be it this side or this side. So it's pretty good for stealth black build. A very nice braided hose, and this hose tube length is at 400mm. Now I did notice something, that for all their Hyperflow series, they do have the tube clip, but for this LightFlow, it does not have that. But it doesn't matter, it's pretty parallel. Now besides this, right, at the end of the tube, these are with rubber butts. Nicely done. You can't swivel this point, else at this end at the pump, you'll be able to swivel. Nice. Now coming to the pump unit, starting off with the measurement, this is measuring at 66.9 in diameter since it's circular, and the height of it is at 56mm. And as for the specification of this pump, it's running a 12 volt DC at a amperage of 0.30 ampere. And for the pump speed, max is at 3100 RPM, plus minus 10%. And this is controllable as the connection point over here is a 4-pin PWM. And on the surface itself, right, there are ARGB effects where you need to connect this 3-pin 5V ARGB to your motherboard. At the base of this front block, it has a very huge copper cold plate, and this tells me that it will be full contact on your IHS, be it the Intel or AMD, to yield good results. Now, coming to the radiator fans, you will be provided with 3 standard 120mm fans with a height of 25mm. Now, since this is a 360, that's why you have 3. And as mentioned, these are pre-installed on the radiator with these long screws, so you don't have to take them out. Okay, just wanting to show you how it looks like individually. Now, the structure of these fans, I would say, is okay. It does flex a bit, but once mounted on the radiator, right, it will be very sturdy. The design of the fan is pretty straightforward. Simple design, not so complicated. See? Now, these are all ARGB fans with 11 blades. And on the design itself, as mentioned, right, one of the side where it has this arrow sign pointing upwards, telling you that the blade is moving this way. And the direction from the left to the right, pointing to the right, this is where the air captured from the back and to push out from the front, where the fan frame is. Now, each of these fans comes with anti-vibration rubber grommets on both sides. There are a total of 4. And over here, same goes to the rest of the fans. Now, as for the fan spec, starting with the model, this is the APA 1225 M12, and it runs at a 12 volt DC of a current 0.25 ampere. Okay, this is written here as 0.3 ampere. Okay, anyway, I'll take it from here. It's 0.3 ampere because on the spec itself it's written 0.25 ampere, but I'll take it to the max. So if you total this up and to plug on CPU underscore fan on any motherboard header, right, it will be safe to run. It's lesser than 1 ampere. Okay, back to where I was. The RPM on this fans, minimum is at 600, maximum is 2000 RPM, plus minus 10%. The airflow is 78.73 CFM, and the static pressure is at 2.39 mm H2O. And when you group them out together and to run, the noise resolution is at 34.3 decibel. Now, this has a very unique way to daisy chain. As you can see that each fans comes with a very short cable, which is proprietary. So you just daisy chain them by clipping the male to the female socket. And do note that there is a clip over here. So when you want to clip it to the next fan, you just clip it on, which is like this. You'll hear a click. Okay? If you want to remove, make sure you press this clip and to remove. I repeat, to clip it on, just clip. Okay, till you hear a click. To remove, press this and to pull. So this is actually how it works, which is quite simple, neat and tidy. So once you have all this clip on, right, as you can see, it's very neat, short and neat, so leaving you with no cable mess. For Intel mounting, things that you need will be the mounting bracket. Now, how to differentiate? This is more square compared to this. This is rectangular. For the rectangular one, this is for AMD. So mount this bracket to the cold plate first, or should I say the pump block, and having the curved section, right, or surface, right, towards the top, and this is actually to the bottom. This is flat. Okay, as you can see, this is flat. The top is curved. So having the curve facing the top and the flat surface towards the cold plate. And to mount it, it will be this direction. Okay, meaning to say the opening over here, right, is away from the tube. If you do it this way, right, it will not clip in. Okay, you will damage the pump. So make sure you do it this way. Once it's done, leave it one side. Now to prepare the motherboard, you will need the back plate. There's only one back plate for this. So just turn over your motherboard, aim for the 4 holes over here. Okay, so align the back plate, remove off the double-sided tape. So when you tape it down, right, it will hold on the frame over here. And I will advise that the double-sided tape, right, make sure the long area is placed over here, and don't do it, okay, do it this way, right, not this way, because this way, right, this will grab partially at the top, plus you will just stick to the logo of any motherboards. So best is to have it this way, fully grab to the frame. So as mentioned, right, aim for the 4 holes where you have the 4 threads over here. The simple way to do it, I always guide my viewers: 1 index finger pressing to 1 point, push towards the hole. See, you can swivel over this way, then it will just align nicely. Now assuming this is placed on the base itself, since I have not removed off the double-sided tape, okay, turn your motherboard over. Okay, now you don't have to follow me right now because I didn't paste the back plate. It's just for me to anchor the back plate to the motherboard so that it will not drop off. Okay, assuming that you have placed flat on the mat with the back plate at the back, mount this standoffs where one side you have it short, one side having long. The long area, right, facing upwards, and this towards the thread on the back plate. So just hand tight. Now especially this corner, it can be tricky as it's very tight. Okay, you can just screw it hand tight. Now one thing, I hope that Montech can be consistent regarding about this. Probably supply this so that your viewers can just, you know, tighten it. I mean hand tighten it at least. Alright, once this is done, right, next thing to do, clean with alcohol on the processor, wipe it dry, and at this cold plate, remove this cover. Okay, once you remove this, right, again apply alcohol, clean it. Once this is done, put this one side. Now back to here, once you clean everything dry, right, apply thermal paste, do a spread method, then prepare this, remove this, clean the cold plate, and you can just place it downwards. Now having to place this downwards, right, anchor the 4 points 1, 2, 3 and 4 to the threads. Okay, align it properly first, then push the whole thing down, wiggle a bit so that your thermal paste, right, will spread evenly. Still holding on to the block, mount the 4 retention bolt. Okay, you can start any side if you want. Just make sure that you hold on to the pump block. Okay, just slowly turn. You don't have to hurry this process. Oh jeez. Okay, once it's grip, right, and you feel a resistance, you can stop. Turning towards this direction here. See, I'm just screwing to hold the retention. I'm not screwing it all the way. So once it stops, right, I'll just stop. And once this is done, then make use of your, still holding on to the block. Use your screwdriver, do it alternately. One turn over here, one turn over here, one turn over here, one turn over here. So repeat the pattern as in like alternately up, down, things like that. So that by the end of time when you screw all the retention bolt, right, when it stop, don't over tighten it. So this will ensure the consistency as in like having a balanced pressure between the cold plate to your IHS. Okay, so make sure you do it alternately so that you have a balanced level. The final step to do is to connect the pump connection and the radiator fans connection. Starting off with the pump connection, we have total of 2 connection point, which is the 4-pin PWM and the 5V ARGB. Now, don't do the ARGB first, do the 4-pin PWM, as this is more important, as this will supply power to pump your pump block, or should I say rotate the motor. So having to say this, right, this should go to the motherboard AIO pump header. Now I'm just going to tilt this so that you can see properly. Okay, let me just zoom in. Alright, there are total of 3 header, 1, 2 and 3. I know the bottom section, right, this is CPU underscore op, and this is CPU underscore fan, and this is the AIO pump. Make sure you plug the 4-pin PWM connector of your pump to the AIO block. If you do not know where it is, right, read your instruction manual. Now the next step, once you've done this, you can connect your ARGB 3-pin 5V, which is over here. Okay, let me just plug it properly. This is done. Over here. Okay, last step, the fan itself, right, over here where it's sticking out. Coming with the accessory, you have this extension cord. Clip this to your radiator fan. Okay, with this 7-pin over here, the female connect to the male. Once it's done, right, it will split into 2 connection point, where again you have one ARGB, the other with a 4-pin PWM. Now this belongs to your radiator fan, right? I'm just going to shift it down again. So having said this, right, you have 1 and 2. This is CPU op, this is CPU fan, CPU underscore fan. Make sure to connect the 4-pin PWM first to the CPU underscore fan. In fact, to most motherboard, right, best is to clip to the CPU underscore fan and not the CPU underscore op. Though I know that Gigabyte for CPU underscore op, right, you can do a individual control, but at all times stick to the plan, click to CPU underscore fan, because this is the master controller. Once this is done, right, now for the 3-pin 5V ARGB, imagine that your motherboard does not have the additional ARGB header. What do? On the pump itself, where you plug, there is a splitter over here. You can just plug this to the ARGB connector of your fan. So when synchronizing, right, the ARGB, your pump and your fans will react the same pattern, the same colors. Unless your board have a separate ARGB header, then you can just connect your fan ARGB to the header, and this is done. For AMD mounting, these are the things that you need: the mounting bracket for the pump, the standoffs, and the retention board. Now first off, I will prepare the mounting bracket. Take note that this is flat on one side and this is curved on the other, having the flat surface facing the cold plate. So to mount this, right, make sure that the opening, this opening over here, is away from the tube. So as mentioned to you, this is on the flat surface, the other is actually a round. So the round should be pointing towards the top and having the flat surface to the cold plate, and this is how you insert in. Once this is done, place this one side. Next thing to do, prepare the standoffs. Unscrew the 4 screws on the original bracket, remove, then fasten down all these standoffs. And to fasten down, right, make sure that this side here that has a round plastic facing downwards, and the long thread protruding upwards. You don't have to over tighten them, just hand tight. And again, I would prefer Montech to provide this, so at least you can do some tightening. Now, reason for this is that in order to tighten this, right, this is a spana shape. So imagine if you use spana, which is metal, and accidentally you scratch on the board, right, it will be harmful to the board. So that's why I say that, you know, probably Montech should supply this. I know this is light version, but do supply this for the sake of the user. Okay, once this is done, right, use alcohol, clean the surface of the IHS or the processor, wipe it clean, apply thermal paste, do a spread method. Once this is done on the block itself, remove this plastic cover. Make sure you remove this, alright? Then clean the surface with alcohol. You might never know that, you know, there might be sticky substance on the cover. Clean it, wipe it dry, then you can apply. Now this is just an illustration, so I did not remove the covering. Okay, probably I'll just do it this way, it's better. So pointing the 4 points, which is this, and this, to the threads. Okay, push it down all the way, you know, bigger a bit, so that the spread of your thermal paste will be spread evenly. Now, holding on to the block, do not let go. Place the retention bolt. Okay, it doesn't matter where you place it. I mean, it's like which direction. Just screw it down till there's a retention stop. Okay, do it on the other side. See, as I change, I will change my hand, having the other hand to support the pump block, and to tighten the, not tighten, to lock down the anchor point of the bolt. As mentioned to you, right, you don't have to over screw it, just turn until you feel there's a retention stop. I'll be doing the last one. Again, once this is done, make use of your screwdriver, still holding on to the block. Do it alternately, starting from the top, 1 round, bottom, 1 round, here, 1 round, and here, 1 round. Continue this style till you feel that your retention bolt no longer go down anymore. As in, like, it stops there. Do not over tighten, just hand tight. Assuming this is done, the next step will be quite easy. Let's see. Okay, let me just turn this way. Easier. The final step will be plugging in the connection point of your pump. There will be a 4-pin PWM and a ARGB connector. Plug your 4-pin PWM first. This is to rotate the motor of your pump. This is more important compared to the ARGB effect. Then on your motherboard, if you do not know where the pump header is, right, read the instruction manual on your motherboard. I know that the white one over here that says pump system. Okay, probably I just zoom in. See? So I'll plug the 4-pin PWM of the pump block to here. Next will be the 3-pin ARGB connector to the 3-pin ARGB header on the motherboard. Okay, this is done. Next thing is you have to feeder. Okay, let me just. You have to feeder with this cable, which belongs to the radiator fan, and this extension cable, which is provided. You need to connect the 7-pin female socket to the male socket, or should I say the male plug on the radiator fans. Clip it on. So once you have this done, at the other end, again you have 4-pin PWM and a ARGB connector. Always feeder with the 4-pin PWM connector first. Then on the connection point over here, okay, look for the CPU underscore fan. Okay, some boards have CPU underscore op. Don't plug on the CPU underscore op. Always a good practice to plug on the CPU underscore fan for your radiator fans, because this CPU underscore fan is the master controller of any board that you select. Okay, so I'll just plug the 4-pin PWM to here, and the final step will be your 3-pin ARGB connector. Now, this board does not have a additional ARGB connector. So what you do is, on the pump block where you plug the ARGB, the cable itself, right, has this splitter. So what you can do is use this splitter, connect to your fan ARGB connector, and this is done. System is up and running. As you can see, the diffusion on the pump and the fans on the ARGB effect, nicely done. A very simple logo on the pump where you have the Montech triangle in a infinity mirror fashion, nicely done. And on the diffusion on the fans itself is also excellent. See, it's very uniform. Now I've set the ARGB effect to follow the temperature. So once it reaches certain temperature, right, the AIO pump ARGB will change color. Now I'm just going to show you the, or should I say, let you listen to the noise of the pump and the pump together with the radiator at load. Starting off with just idle with the pump running at max speed. You can have a look on my right. This is where you have the radiator fans and the pump. The pump right now is running at 3100 RPM plus minus 10%, which is hitting the mark. So this is my microphone. Going to do a sound test. Now I'm just going to place this near the pump. Now this is how it sounds like when the fans are at idle, which is around 1300 RPM, and the load of the pump is at full speed. So this is how it sounds like with the microphone near the pump. I'm just going to move the microphone away and to clip it over here. Now the microphone is about half a feet off from the pump and 1 feet away from the radiator fans, and do a sound test. This is how it sounds like at idle. Now I'm just going to ramp up the Cinebench, and when I ramp up the Cinebench, you can witness that the fan RPM, right, will go up to the max, which is 2000 RPM. Here we go. This is how it sounds like at load. There you have it, at load together with the pump and the fans. That's how it sounds like. I'm going to let it idle again and I'm going to do another run to let it load so you can witness the noise of it. Now as the pump goes green, right, it means that it's at idle. So this is at idle. I'm going to ramp up the Cinebench again, and this is how it sounds like at load. There we have it, the full load, as you can witness. Now if this is plugged into the case itself, right, first of all, I can't hear the pump at all. If you can hear it, based on the fact that the microphone is very near the pump, and when it's at load, right, yes, it does create noise, but the noise from the fans itself, right, is just a subtle hum. You can't really hear a sharp pitch also. Nicely done. So imagine that if this is in a case, right, it's going to be much quieter. Now I'm just going to test the thermal on how well this Liquid AIO can cool down my 9950X. And before I do so, right, this is the temperature in my room, which is 30.5 degrees Celsius, and I'm coming from a hot and humid country, so my room is hovering around 30 to 31 degrees Celsius, and I deliberately do not turn on the aircon. Just want to see how much this Liquid AIO can perform. I have continuously run Cinebench together with Firmark for a couple of times, and this is my 6th time. I've just finished the 10 minutes throttle test. In fact, previous tests I've done, right, is the 30 minutes and the 10 minutes, and this time round I'm just going to run 10 minutes and let it idle. As you can see right over here, the timing, I'm letting it idle, and shockingly that the idle temperature is still 46 degrees Celsius, and having the fans to ramp up, I mean not say ramp up, at idle of 1300 RPM, and the pump is at full. Now just to show you that I'm using the 9950X processor, and as for the motherboard, I'm making use of the MSI B850M mortar, and as for the RAMs, I'm using the King Bang RAMs, as you can see over here. Now what have I done on the PPO settings? Looking at Ryzen Master itself, right, all the PPT, TDC, EDC, they are of the default. I've not changed it. Okay, let me just close this for a while. Then else, for the per die on the curve optimizer, I've done my first 8 core with -15 magnitude, and the last 8 core with -10. And as for curve shaper, can't see it on Ryzen Master, but I'm just going to show you over here. Now there are 3 frequency, which is the medium frequency, high frequency, and the max frequency, and each frequency have 3 temperature. So I've set the medium frequency with all the temperature as -15, the high frequency with all the 3 temperature as -10, and last but not least, the max frequency with -0.5 on all the temperature. Now I also did a vCore offset, which is -0.05, and for the SoC voltage to 1.15 volt. I know that it can run. I've tested on either 64. Now, so I will be showing you live instead of doing the recording. So right now I'm just going to place all the stats first. Now having said this, right, just observe all this temperature over here, inclusive of the CPU temperature, and how the pump react, and how the radiator fans. In fact, the pump is at full speed. So right now I'm just going to run at 10 minutes, and I'll talk about the result by the end of probably 2 minutes or so. Here we go. Last 2 minutes or so. Well, take a look at the bar first. This is consistently running at a flat rate, pretty consistent. This is in fact the average of all the 16 core, which taken from here. So it's pretty consistent, and looking at the peak speed, right, it's around 5 gig or so, which you can see all the cores over here. Nicely done. And best part is that looking at the temperature, it's hovering 76, 77, around there, and most of the time it's in fact 76 degrees Celsius. And the pump, as I told you, is running on full max speed, and the fans, do check out, they are consistent at 2000 RPM at load. And the rest of the temperature is even greater, like the mumbo temperature, the VRM temperature. In fact, the MOS is the VRM, and the chipset, followed by the RAMs and the drive temperature. All this is within the 55 degree mark, which is fantastic. Now I'm just going to wait for the thing to stop at this score, just to show you. Now this is pretty amazing. In fact, the reason why I tested this numerous of time, based on the fact that I don't believe my eyes. Now I'm thinking of the original thermal paste that Montech have issued on this liquid cooler. Okay, and this is my first time applying. I didn't change the dressing and such, so I was shocked when I first tested it and let it idle, because the idle temperature is 46 degrees Celsius, and at load, right, it's always at 76, 77. So what can I tell you about this liquid AIO? At a $69, or should I say a $70 USD price point, that can perform this temperature, it's pretty impressive. Now I wouldn't expect this, so-called LightFlow to perform this good as compared to the, I thought the HyperFlow Digital, which I've done the review on, it's already on the top mark. Right now, this liquid AIO are not with the E28 thick fans, okay? They are just default 11 bladers. So I was expecting probably around 83 or 82 or 83 degrees Celsius, but it didn't happen. Alright, looking at the score, 42,161. By default, if I don't do curve optimization and such, right, my score on this 9950X, right, will be 39K. So this tells me that, with this temperature and such, right, there are more headroom for you to overclock with this liquid AIO. My impression about this Montech LightFlow 360, well, when I unpack it, to be honest, I wasn't impressed, as I see some missing item, things like the tube holders and the butt, where I used to see on the HyperFlow series, right, all with the silver or chrome, butt over here. Same goes to the pump. So these are some of the minor setback. Yeah, it has the same quality sleeving and such, and when I touch the fans, right, it's rather flimsy, but as mentioned, once you mount on the radiator, right, it's of a different story. It will be very sturdy, and also the attention to details on the fans itself, right, is not as good as the E28. But when I fire up this thing, right, expecting that the diffusion might not be as great as compared to the HyperFlow series, to my surprise, look at it. It is so nice looking. The diffusion is very uniform. Like the pump block, I like this logo a lot with the infinity mirror effect. Is simple. Hopefully that in future they have this reading at the triangle. That would be fun. It's like the CPU temperature cycling to the GPU temperature at the center of the triangle. Probably this is a suggestion to Montech. Now next thing is the diffusion on the fans itself. Take a look. It's very uniform. Nicely done. Now next is about the performance. I wasn't expecting this to perform. I've tested again and again, 6th time. The last time at the 6th period, I've shown you the result. I can't believe my own eyes. This liquid cooler idle is at 46 degrees Celsius, as good as the HyperFlow Digital, which I've done the review not too long ago. If you missed that, you can click on my top right hand corner. Now back to the performance. I wasn't expecting it to have idle at 46 degrees Celsius after 5 rounds of run, be it 30 minutes or 10 minutes on Cinebench and Firmark, and on the 6th run is still idling at 46 degrees Celsius. And when I run the load, it's more impressive. Consecutively, I've been running the test until the 6th time, it is still hovering at 76 degrees Celsius. In fact, the max is 77 degrees Celsius at load. This is fantastic. I'm not too sure what Montech have done with the pump or the fans. The HyperFlow Digital is so fantastic. Okay, almost the same result as, or should I say identical result as the HyperFlow. Now HyperFlow Digital has an advantage whereby it is able to pull up to 5.1 gig consistently. This is able to hover or pull at 5 gig on a 9950X processor, and in a hot and humid country, as I show you, see, the temperature doesn't change. I've not turned on the aircon. Fantastically. Montech, congrats again. This liquid AIO is very hard to beat at a price point of 70 USD. Man, if you guys are into performance AIO and doesn't need the fanciness of the LCD display and such, right, probably you can get this AIO. It performs very well and it's cheap. Best of all, the construction, right, the radiator, the tube, everything is similar with their Hyperflow series. It's just that the linings, like the design, like the chrome butt and such. But overall, it is still very pleasing. Now, congrats to Montech. You have done another giant liquid AIO at a very good price point. Hope you guys have actually enjoyed what I've shared with you, and I'd like to thank Montech to have provided this unit for me to share with everyone. Now, before I end, forget to mention, there is one thing that I hope Montech can do in future. If you do come with budget liquid AIO, right, do supply this. This is very helpful for us to mount the standoff on the motherboard, to have a secure mount, you see. Alright, back to where I was, thanking Montech to have provided this unit. Now, if you guys are new to my channel, welcome to my channel. If you like my content, do remember to subscribe and to click on the notification bell button. And do me a favor, if you like this content, help me to click on the like button, as this will help my channel. With this said, thank you, goodbye, see ya.